Simulation of a half adder with 2 gates, using Tina on a Raspberry Pi 4B computer. In this tutorial video we will show you how to run Tina on Raspberry Pi 4B. Raspberry Pi is a powerful, compact mini computer. It's affordable, runs various operating systems, and is perfect for learning or projects. It can also run Windows applications using the Wine Windows emulator, including Tina. Wine, originally an acronym for Wine is not an emulator, is a compatibility layer capable of running Windows applications on several operating systems, such as Linux, macOS. Instead of simulating internal Windows logic like a virtual machine or emulator, Wine translates Windows instructions into macOS or Linux instructions directly, outperforming other methods in terms of speed and efficiency. Let's start up Tina on the Raspberry Pi. We have already installed Tina offline version in Wine and have the exe file link on the desktop, and just need to click on that link to run Tina. After some time, we will see a little window pop up. And then, Tina will load in. The half adder is a simple combinational circuit to add 2 single binary digits and provide the output plus a carry value. It has 2 inputs called A and B, and 2 outputs S, sum, and C, carry. In this tutorial video we will create and test a half adder circuit in Tina. We will use an XOR, exclusive OR gate for the sum and an AND gate for the carry, high-low switches and voltage pins for the outputs. To start with, we will draw the schematic diagram of the half adder.
First, select the exclusive OR gate from the Gates toolbar. Place it on the workspace. Then select and place the AND gate. Next, from the Switches toolbar, select 2 high-low switches and place them as shown in the video. Next, select and place 2 voltage pins from the Meters toolbar. Finally, connect the components with wire. Okay, let's rename VF1, VF2, and the switches. Double-click the upper high-low switches and change its label to A. Next, rename the lower high-low switch to B. Rename VF1 to sum and VF2 to carry. And the circuit is now complete. Now, to test the circuit, click the Dig Interactive button. If Tina is in a different interactive working mode, select Digital from the interactive menu. The mode name on the Interactive Mode button will change to Dig. Alternatively, you can use the narrow Select Interactive Mode button to change the interactive working mode. Play with the switches toggling between low and high levels to produce all the input combinations. If both inputs are low, sum and carry are also low. If just one input is high, then sum is high too and carry is low. If both inputs are high, then sum is low and carry is high. Now modify the inputs to plot a time diagram and replace the switches with pulse sources. Delete the 2 switches. Click the Sources tab, then select 2 pulse sources from the toolbar and add them to the circuit. Finally, select the grounds from the basic toolbar and connect them to the pulse sources. To produce all the needed input combinations for a time period of 1 second, set the PS1 pulse source to high from 0.2 seconds to 0.6 seconds. Double-click the pulse source PS1, then in the dialog window, click the Pattern field and the three dots. To add new states, click the Add New button in the Set Moments and Levels dialog window. Enter the value 0.2 into the field Moment Number 1. Next, switch the level number 1 to High. Click the Add New button again, enter the value 0.6, and leave the level number 2 low. Save these settings by clicking the OK button. Press OK to close the pulse source dialog. Next, set pulse source PS2 from 0.4 seconds to 0.8 seconds to high. Add more voltage pins to the inputs of the circuit to see the input signals on the diagram. Rename VF1 into A and VF2 into B. Also add :1 to the end of label A and :2 to the end of label B to display these signals at the top of the diagram. Also rename sum to sum:3. These settings will separate the signals and determine their orders in the diagram. A will be at the top, followed by B, sum, and carry. Finally, run digital timing analysis from the Analysis menu. Click the Analysis menu and select Digital Timing Analysis. Set the simulation end time to 1, then press OK. Now all signals are displayed separately in a time diagram.
This concludes our demonstration on simulation of a half adder with 2 gates using Tina on a Raspberry Pi 4B computer. Thank you for watching. For more information, visit our website and YouTube channel.